Howdy there, boys and girls. It is Coach Goo once again with another fun-filled, action-packed, flipped geometry classroom video. And guys, what is this? First thing that comes to your mind when you see this, did you say kite? Did you? Oh my goodness, kite. That's right. Yes, it is a kite. That is what we're gonna be doing today for the nose. This is our final shape in our quadrilateral kingdom that we're gonna learn about, and it is the kite. It is actually a shape. Oh my goodness, that looks exactly like my picture if you turn the screen sideways. So we're gonna be learning about the properties of kites. So let's read together what is a kite in geometrical terms. A kite is defined as a quadrilateral, that's four-sided figure, with two pairs of consecutive sides that are congruent. Two pairs of consecutive sides that are congruent. That means that you've got two sides in a row. Look, here's one side. Bam. Let me use different colors. It makes it more obvious. One side, and then the side right after it. Boom. These are congruent. That's one pair. Then we've got the next side right here. Boom. And then the side right after it. Those two sides are also congruent. So we've got two pairs of congruent consecutive sides. All right. Now let's take a look at the property of these sides. What are the properties? The two pairs of consecutive sides are congruent. So if I were to write an equation, I'm going to give you one. Check this out. EF is congruent to EH. Look, EF, that's right here, boom, is congruent to EH. What is the other statement that I'm going to write? IF is congruent to IH. That's right, nice. And there's no parallel sides. No parallel sides. Okay? All right, moving on. Properties of the diagonals. Properties of the diagonals. Now, in a kite, the diagonals are going to be just like the boom and boom. So one diagonal is going to bisect the other. So that's similar to some of the other properties we've had. What I write, if I'm going to say EI bisects, which line does EI bisect? It bisects FH. Good. And that means that, look at this, FG, watch, I'm going to do right there, boom. That's congruent to, FG is going to be congruent to GH. Bam, perfect. Because it is being bisected by the diagonal. Now, that's only one of the diagonal bisects the other. That means only one of these diagonals is going to have two congruent segments. All right, next up, diagonals are perpendicular. You can see that our two diagonals here intersect at a right angle. That means they're perpendicular. So I can say that EI, bam, is perpendicular to FH. And then lastly, one diagonal bisects one pair of angles. So, if you take a look at this, only one diagonal bisects one pair of angles. Now look at our picture. IE bisects. Which one does I? Take a look at IE now. That's going to be this red line. IE bisects which angles? It bisects angle I and angle E. These two are perfectly bisected. Look, boom, those are the same. And these are the same. Wow. And that means if I wanted to write something, I could write angle FEG. That's going to be this angle right here. F to E to G. That angle is congruent to angle HEG. That's from here to there to there. And then also angle FIG, angle FIG, is congruent, oh my gosh, angle Fig is congruent to angle HIG. There we go. That's this and this. Those two angles are congruent. All right, cool. So that is the end of the properties of the diagonals. Now, finally, the properties of the angles. So one pair of opposite angles are congruent. One pair of opposite angles are congruent. So look, we've already found our bisected pair. That's going to be here and here. Now only one pair of opposite angles are congruent. That's going to be this pair of angles right here and here. So on our picture, angle F is congruent to angle H. Notice angle E and angle I are not congruent. Let me draw it out for you. Look, E looks like this, okay? Now I looks like this. Well, let's exaggerate. I looks like this. Angle I is greater than angle E, so they're not congruent. Bam, that's not true. But look at angle F, boom, and angle H, boom. They're the exact same. So those two angles are the opposite angles that are congruent. And the interior angle sum is 360 degrees, just like every quadrilateral. That means if I add the measure of angle E plus the measure of angle F plus the measure of angle I plus the measure of angle H, that's going to equal 360 degrees. And that is it for all the properties. So now let's take a look at how we would use these in some problems. So in examples 1 through 3, we're finding the measure of the numbered angles in each kite. So we're going to use the properties to find these angles. Look at the measure of angle 1 over here. How am I going to find that in number 1? Remember, diagonals always perpendicular intersect. So boom, that's a right angle. So the measure of angle 1 equals 90 degrees. Wow, that one was quick. How am I going to find the measure of angle 2? Well, check this out. If that's 90 degrees right there, this angle right here is also 90 degrees, then these two angles down here are the same, 22 degrees, 22, and that leaves me with 2. Remember, this is a triangle. Let me outline it for you. That's a triangle. Now, I see that I have 90 degrees, and I have 22 degrees. Let me add those together. That gives me 112. And remember, the total number of degrees in a triangle is 180. So, if I just do 180 minus 112, that gives me 68, and that is the measure of angle 2. Equals 68. Boom. There we go. Looking at number 2 now. How am I going to find the measures of angle 1 and measure of angle 2? Remember, the total in any quadrilateral is going to be 360 degrees. And then remember, one pair of opposite angles are congruent. So these two angles are going to be the same. So let's just see how many degrees I have left after I subtract the 54 and subtract the 90. So 360 minus 54 minus 90. That's going to leave me with 216 degrees, right? But I have two angles between this 216 degrees, and both of these angles are the same. So I'm just going to do 216 divided by 2. That is 108. So the measure of angle 1 and the measure of angle 2 are both 108 degrees. There we go. All right, so I want you guys to try number 3 on your own. All right, moving down to examples 4 through 6. Find the value of the variable in each kite. Oh my gosh, Coach Goo, what the heck? Those aren't numbers. We're gonna do some algebra. Yes. All right, so this time we're gonna use algebra to find these missing angles. Now, take a look at number 4. That's the one on the left, number 4. There's these two angles in there. How am I gonna use these angles to find x? Wow, look at this. That's a triangle. I know this is 90. What do all three angles add up to in a triangle? They add up to 180. So I can do 90, because that's this perpendicular part right there, plus x plus 6, that's my angle over here, plus 2x, that's my angle right here, And all that added together equals 180 degrees. So now I'm going to combine like terms. 90 plus 6 is 96. And x plus 2x is 3x. So plus 3x equals 180. Now subtract 96 from both sides. 3x equals 84. Then divide by 3 on both sides. Boom. X equals 28. And I've solved for x. Wow. That was crazy. Dang. All right, number 5. How am I going to find these? How am I going to use these two expressions to write an equation? Well, remember, one pair of opposite angles are congruent. These are the opposite angles that are congruent. If they are congruent, then I can say that 3x plus 5 equals 4x minus 30. And then I'm just going to use algebra to find my answer. Subtract 3x from both sides. That leaves me with 5 equals x minus 30. Add 30 to both sides. 35 equals x. Boom, there it is. And then for this last one, you're going to have to find x and y. It's two different equations you're going to have to write. But once again, just algebra problems. So I want you guys to try number 6 on your own. And that's going to wrap it up for our kites. And we are done learning about different types of quadrilaterals. So, good luck to you, and I'll see you in the next one. Peace!